Chapter 9.4, Algebra 1. The third method that we're going to introduce to you on how to solve for systems of equations is the addition or subtraction method. I will never, ever use the subtraction method. I will always use the addition method. I think the subtraction method is wrought with errors and the ability to make silly mistakes. So I won't use the subtraction. I will just take the time to do addition. And the first two methods that we have already seen in chapter 9.1 was graphing, 9.2 was substitution, 9.3 was using substitution with word problems, and now we're going to learn the addition and subtraction. So what we see is instead of isolating for a variable and substituting it in order to eliminate one of the variables, that's what our goal, our overall goal with all of these is to eliminate one of the variables. So if we see this as a plate, as a fulcrum, you have 4x minus y on one side, you have 7 on the other, and then you have another equation. I'm going to actually move this down. You have another fulcrum that has the other equation. And it's sort of like this because they're equally balanced, meaning 2x plus y is going to have the same weight as 5, and 4x minus y is going to have the same weight as 7. So what we're doing here, actually let's do this also. Yeah, I knew that wasn't gonna, this may, not order, this may end up blowing up in my face. Let's group that. Sorry, this is doing something that is way too sophisticated and I'm overthinking this step, but it's okay. I'm gonna, oh, that's nice. Oh, yes. Okay. So what they're talking about is, hey, let's take both of those and let's put them on the same fulcrum. Let's take this, copy, paste. Let's take that and put it on this left one. Let's take this and copy and paste and put it on the fulcrum. And let's take this, copy, paste, and put it on the right side. Whoa, that was weird. I don't know what happened there. Oh, it's separated. And put it on there. And let's take this, copy, and paste, and put it over here. And we are going to add those two pieces together. And that should create an equivalent new equation. You see that we have the two equations added together here and the two equations on the right side of the fulcrum together. The beauty of that is we enjoy that, or it's advantageous for us because we have a positive y and a negative y. And that positive y and negative y cancel, and we notice that we're just left with x's. And then we have two constants on the right side, so we can isolate and solve x equals 2. We can plug it back in and find out what y is. So that's what addition is doing. It is putting, one of the important things is you notice that this format or the template is ax plus by equals c. It can be any format, but since the top one is in this format, the bottom one has to be in an identical format. That is the benefits of that. So it doesn't have to be in standard form. It can be in slope-intercept form. It can be in any type of form. It's just that both equations need to be in similar. This is the subtraction. What it's doing is it's subtracting this bottom equation from the top equation. It's subtracting this from this. So in a sense, it's this. And I think the difficulties is, okay, now you got to distribute this to each one, or you're thinking, subtracting. That's way too much work for me. That is way too much. So you get this becomes negative, this becomes positive, this becomes negative. That's why the C's cancel. That's why you're left with 4D, and this is why you're left with -8. That, to me, changing all those signs, keeping track of which ones are positive and negative without writing them. It's just eyeballing it. That just, to me, that's going to be a little bit challenging. So we want to look at these two equations and we want to see, hey, if I add these together, if I combine the columns, if I combine the x's, if I combine the y's, and if I combine the constants, can I eliminate one of the variables? And in this case, yes, I can. The y's will cancel out. We are left with 2x equals 8. We'll divide both sides by 2, and we get x equals 4. And then we can take either of those equations. I'm just going to take the top one, and I'm going to plug this x value back in, and we again end up with only one variable, which we can isolate and solve for, and we have our solution. So nice. And we can check it. 4 plus 2 is 6. 4 minus 2 is 2. That worked out. So we're going to do that every single time. We're going to look and see, do my m's cancel out? No. Do my n's? Yes. Then it's advantageous for me to do this. There will be one more trick to this, but we'll just show how we're going to combine these. The n's will cancel. We're left with 2m equals 18 divided by 2, m equals 9. Nice and efficient. We can take that top equation, m plus n equals 12. 9 plus n equals 12. Minus 9, n equals 3. So mn, my coordinate is going to be alphabetical order, so I'm going to put my m value before my n value. I look and see, yes, this works. We can look automatically and go, oh yeah, I see the y's will cancel. That's nice. My y's cancel. They cancel out. I'm left with 3x equals 6. Divide by 3, x equals 2. And now I'm going to take, I'll take the bottom. No, I don't want to take the bottom one. Bottom one's not fun. Top one's probably better. So 2x plus y equals 3. I could do either one, you understand. I'm going to plug that in. I like a positive y. So minus 4, y equals negative 1. And we get the coordinate 2, negative 1. Nothing cancels here. So they would like you to do the subtraction. So I'm going to introduce something to you called the multiplication. I can create an equivalent equation. By manipulating, I can manipulate this bottom equation. If I wanted to get rid of the x's, I have positive 2x here. What do I need to be in the denominator? I would need it to be negative 2x. That would be the thing that cancels with the positive 2x up here. So if I multiply this bottom equation by negative 2, it now becomes negative 2x minus 2y equals negative 8. Remember, I have to multiply all three parts. And then I'm going to bring this equation over. 2x plus y equals 5. Now when I add, the x's cancel. I'm left with negative y equals negative 3. I'll multiply by negative 1. And we get y equals 3. And now I can choose any of the equations. I'm going to keep the nice easy one. I'm going to plug in 3 for y. Minus 3, x equals 1. So we get the solution 1, 3. I will show you, let's clone it. Let's erase the ink. What if I wanted to get rid of the y's? What would I need to do? This is a positive y. I would need this to be a negative y. So what can I multiply to make that negative y? I can multiply it by negative 1. So this equation now becomes negative x minus y minus 4. And that top equation just stays along. 2x plus y equals 5. We see the y's cancel. We're left with x equals 1. And yes, remember, my x did equal 1. So, and then we can plug it back in here. 1 plus y equals 4 minus 1 minus 1, y equals 3. We still get the same solution. And so there's no one way that you can use. You could also do the subtraction, and you would get, again, x equals 1 just by subtracting the bottom equation from the upper equation. I'm not going to do subtraction. I'm not a big fan of it. I just taught you the multiplication, the creating a new equation by multiplying. It's proportional. So that's definitely a little bit advanced, but we're just going to do this. The n's can cancel. We're going to add these. That makes 8m equals 24. Divide by 8. Divide by 8. M equals 3. I'm going to take one of the equations. We'll say 3m minus 2n equals 11. 3 times 3 minus 2n equals 11. 9 minus 2n equals 11. Minus 9 minus 9. Negative 2n equals 2. And then we will divide by negative 2. N equals negative 1. We are going to write the point in mn coordinate. We cannot. I'm going to multiply it by negative 1. So this equation becomes negative 5m minus 3n equals negative 7. We get 12m plus 3n equals 0. And yes, this is just like subtracting. But we get to see it. I am more of a visual learner, so I'd like to see those negatives so I see that they are opposite. I like to see 12m minus 5n m to get 7m equals negative 7. Divide by 7. M equals negative 1. And then we'll take the equation 5m plus 3n equals 7. I just thought of something funny. Minus 1 plus 3n equals 7. Negative 5 plus 3n equals 7. Add 5. 3n equals 12. Divide by 3. Divide by 3. N equals 4. M, n is the coordinate. These will cancel. My x's cancel. And that leaves me with negative 4y equals 8. Divide by negative 4. Divide by negative 4. Y equals negative 2. So this is even faster than substitution. So when we see that they can cancel, that's much better than substitution and is definitely way faster than graphing. Imagine having to graph those. Woo! So we'll take 6x minus 7y equals 14. 6x minus 7 times negative 2 equals 14. 6x plus 14 equals 14. Minus 14. We get 6x equals 0. Divide by 6, divide by 6, x equals 0. And 0, negative 2 would be our coordinate. They do not cancel. I'm going to multiply the bottom by negative 1. Remember, you have to multiply all three terms by negative 1. And then we'll bring that top equation. 4a minus 5b equals 10. The b's are going to cancel. You're left with 2a equals 10. Divide by 2. A equals 5. We'll take the bottom equation. 2a minus 5b equals 0. 2 times 5 minus 5b equals 0. 10 minus 5b equals 0. Minus 10. Negative 5b equals negative 10. Divide by negative 5. b equals 2. A, comma, b is our coordinate order. None of these cancel naturally, so I'll multiply by -1. This equation becomes -2c minus d equals +3. This is 2c plus 3d equals 3. The c's cancel. 2d equals 6, divide by 2, d equals 3. 2c plus d equals -3. We'll plug in d, which is +3, equals -3 minus 3. 2c equals -6. Divide by 2. Leaves us with c equals -3. We have c d. Keep going. These naturally cancel. The y's cancel. You're left with 6x equals -6. Divide by 6. X equals -1. 2x plus 3y equals 4. 2 times -1 plus 3y equals 4. -2 plus 3y equals 4. We always simplify before moving. Now we will isolate, get rid of things being added and subtracted first. Divide by 3, y equals 2. So -1, 2. X equals 15. X equals 3. We got, we'll use, I don't know if we need an arrow. We'll just use the bottom equation because we're solving for y, so it'll be easy. Y has a coefficient of 1, so we don't have to do any other than moving the constant over. And we get 3, -1 for our coordinate. These do not cancel. I'll multiply by -1. -2x plus 5y equals -17. Doing that nice simple task makes it a little bit easier in my book. If you can see it, if you can do it consistently correctly, good for you. Use the subtraction method. I am going to continue to use this technique. Call me stubborn? Absolutely. Talk to my kids. Students and biological children. -8 minus 5y equals 17. Add 8. Add 8. -5y equals 25. Divide by -5. Y equals -5. My two coordinates are negative, or my coordinate is -4, -5. Yeah, we're not really changing much. We're doing the same technique, and that's the beauty of doing this many problems, is to get well versed at it, see all the tricks, how they try to change it up a little bit to see if they can see if you can make a mistake. I'm going to try not to make a mistake. My arm is falling off of my shoulder right at the moment. Y equals -2. And let's take 9x minus 10y equals 2. We're going to plug in -2 for y. 9y plus 20 equals 2. Minus 20 minus 20. That will give us 9y equals -18. Divide by 9, divide by 9. Y equals -2. Oh, did I do y on both times? Oh, I see what I did. That was interesting. That's an x. That's an x. That's an x. And this is an x. That was really weird. -2, -2. Let's just make sure and check that I did it correctly. I'm plugging in for y. That's positive 20. Good. That ends up being -2, -2. These don't cancel. I'm going to multiply by -1. I could try to get rid of the m's, but keep it simple. Let's not make it let's not overcomplicate things. Let's multiply by -1. That is going to be your easiest equivalent equation. The n's cancel. You're left with -3m equals -21. -3, m equals 7. Take the equation, 8m plus 12n equals 20. 8m is the value of 7. 12n equals 20. That's 56 plus 12n equals 20. Minus 56. Minus 56, 12n equals -34? No, 24. -24, 56, no, 36 equals -36. Divide by 12, divide by 12, n equals -3. We have my mn. And remember, if you ever question it, plug it back in. 5 times 7 is 35. 12 times 3 is, 12 times -3 is -36. 35 minus 36 is -1. That works. 8 times 7 is 56. Minus 36 gives us 20. So it worked. These will cancel. We like those that are set up for addition. 8a equals 32. A equals 4. Let's use the top one. We don't need the arrow. 3a plus 2c equals 30. 3 times 4 plus 2c equals 30. 12 plus 2c equals 30. Minus 12 minus 12. 2c equals 18. Divide by 2, divide by 2. C equals 9. Oh, A and C, how weird is that order of coordinates? But it's still alphabetical order. Yay! This still cancels. We don't have to manipulate. 13n equals 13. Divide by 13. N equals 1. 3m, I don't have to write an arrow. Plus 4n equals 7. I just need to choose one. 3m plus 4 times 1 equals 7. 3m plus 4 equals 7 minus 4. 3m equals 3. Divide by 3. M equals 1. Mn is good. How many? Oh, all right, we got a couple more. Couple more. 5 more. Okay, 5 more. Here we go. I like the last couple at least. They are kind of tricky with fractions. -4x minus 5y equals -6. Let's bring that equation. 4x minus 2y minus 8. The x's cancel. -7y equals -14. Divide by -7y equals +2. 4x plus 5y equals 6. 4x plus 5 times 2 equals 6. 4x plus 10 equals 6 minus 10. 4x equals -4. Divide by 4. Divide by 4. X equals -1. So we get the point -1, 2. These cancel. This is not the hard one. 10a equals -30. Divide by 10. A equals -3. 4a plus 5b equals negative 32. 4 times negative 3 plus 5b equals negative 32. Negative 12 plus 5b equals 32. Add 12, add 12. Oh, are we going to get a fraction? Let's make sure we did this correct. That is 10a. That is negative 30. That gives us negative 3. That gives us negative 12. That's negative 32. Okay. 5b equals 44. Divide by 5. Ugly. b equals 44 fifths. Blech. Negative 3, 44 fifths. And this is one where we would never be able to get that solution through graphing because it wouldn't be on a grid line. So, okay, now I guess we're going to get a little goofy with our fractional answers. So that's 20x equals 60. That's not goofy yet. X equals 3. I'll use the top one. 7x minus 11y equals negative 1. 7 times 3 minus 11y equals negative 1. 21 minus 11y equals negative 1. Minus 21 minus 21. Negative 11y equals negative 22. Divide by negative 11. Y equals 2. So I get the 0.32. I'm going to go back because I guess I made a mistake. I mean, I think I made a mistake. Let's check it out one more time. 6 and 4 is 10. So that is correct. 4a plus 5b. I solved for a. I plugged it in for a. That's a negative. Yep, that's correct. Negative 12. Got it. Found my mistake. I knew I couldn't. I was like, I knew it. I felt it. I forgot to write negative 32 there. Negative 32, Mr. McCall's line, 5b equals negative 20. Divide by 5, b equals negative 4. I was just like, you want to know what? You can't go from fraction to, so I caught it. I felt it. And if you feel it in your bones, you do enough of these, you feel in your bones like you've made a bit of a mistake. So don't ever feel bad about going back. If you get this little itch in your head, hey, that just doesn't feel right. Go back. And I looked at it. I looked at it a couple times. And I hadn't caught that negative, that miss of the negative. So I went back, I checked, and I took my time. I didn't rush through it. I looked to see. And as we know, where are most silly mistakes? With negatives. Yes, they deal with negatives. All right, let's get back to this one. These are fractions, but the y's still cancel, which is nice. Now we just need to know how to add fractions. 1/2 plus 3/2 is, well, 4/2 x equals 4. 4/2 x can be 2x equals 4. Let's divide by 2. X equals 2. And now we'll take a, that doesn't matter. Let's do 1/2 x plus 1/3 y equals 2. Let's plug in 1/2 times 2 plus 1/3 y equals 2. Denominator, numerator, we're left with 1 plus 1/3 y equals 2. Let's subtract 1. 1/3 y equals 1. Let's multiply by the reciprocal, which is 3. Y equals 3. So we get two whole numbers, 2, 3. Didn't make it harder, didn't make it worse. So let's multiply. Nothing cancels, so we'll multiply this bottom one by negative. Negative 5/4 x plus 1/6 y equals positive 11. Let's move this equation. 3/4 x minus 1/6 y equals negative 7. My y's will cancel. We're left with negative 2/4 x equals 4. Let's simplify that. Let's multiply by the reciprocal, which is negative 2. X equals negative 8. Let's pick an equation. We'll pick the bottom one, 5/4 minus 1/6y equals negative 11. We'll plug in negative 8 for x. We can move all this a little bit. Let's move you over a tad, just for a little bit of space. Good. We have the 4 in the denominator is going to cancel with the 8 in the numerator. That makes negative 2 times 5 is negative 10 minus 1/6y equals negative 11. We'll add 10 to both sides. Negative 1/6y equals negative 1. Multiplied by negative 6, which is the reciprocal of negative 1/6. Y equals positive 6. And so my coordinate is negative 8, 6 is my solution. We're done. So we see when it's super easy, super fast. We see when it all of a sudden slows the process down and we got to do a little bit more work. But for the most part, these are all relatively simple, the same style of problem. So take your time, addition. If you want to implement the subtraction, go for it. Good on you. And good luck.